Okay, so my name is Sachiko Nakajima, and it's an honor to be here. And so I brought piano here. So today, I'd like to start with the piano. Actually, I'm a jazz pianist and a composer, as well as a mathematician, and I'm also working for global leader development solutions. But first, as a jazz pianist and composer, I'd like to play one original song called Flower of Hope. And this was made after Tohoku earthquake. And so right now, I'd like to dedicate this song to those who are suffering in Kumamoto and also for you. Yes, thank you. So the title is Flower of Hope. We say Kibou no Hana in Japanese. much. Yes, this song is called Kibo no Hana, and I really love music. Yes, and I like to play, but also I like to compose. I really love to compose music. So today I'd like to tell you about music and mathematics, which I also love. Yes, and also some kind of education. Yes. Yeah. So I'd like to start my talks. So first, I'd like to introduce myself again. I have actually three phases. One is music, and I'm a jazz pianist, composer, and I'm sometimes play some gigs here in Tokyo, or sometimes in Europe. And also, I'm also a big fan of mathematics. From 13 years old, I've been really absorbed in mathematics, and I went to International Mathematics Olympic. Do you know? International Mathematics Olympic. Thank you. So in 1996, when IMO was held in India, I went there, and I got a gold medal there. And in 1997, I went to Argentina, and I got the silver there. So in my junior high and high school days, my daily lives were almost devoted into mathematics. I really loved that. And at university, I encountered with music, so I devoted my life into mathematics and music in my university life. Yes, my major was number 30, so I really love prime numbers. Yeah, okay. So, and also my other phase is for education or learning and development. I'm working at Phoenix Consulting, which is a global leadership development, which provides global leadership development solutions. And also, I'm doing some kind of workshop or lectures all over Japan, music and math. Yes. And sometimes I supervise some drama based on music and mathematics, like Hard Nuts. Do you know Hard Nuts? Hard Nuts is a drama which very talented girl try to solve some problems like a detective. Yeah, it's and Ai Hashimoto, who was also acting in Ama-chan. Yeah, was a main actress there. So on the third story, they used music and mathematics as some kind of trick. Yeah, so I supervised that. And yeah, so for me, music, mathematics, and education, learning and development are all connected for me. And it's quite similar to each other. So in my life, it's all connected, and it's all connected to human beings around me. So today, I would like to introduce some of my viewpoints on mathematics, music, education, and introduce some of my activities. So as for mathematics, first I would like to start with mathematics. For me, mathematics is first beautiful and mysterious. I would like to show you some equations which I think really beautiful. And also, in mathematics, we need a sense of empathies, something like empathies, or sense of essences, which we call jocho in Japanese. Do you know him? Yeah, his name is Kiyoshi Oka Kiyoshi sensei. He's a very famous world famous mathematician, and also quite famous for his strange, funny behavior. Yeah, but he says that in mathematics, what is most important is jocho over logic. So he says, in order to polish your jocho, you have to learn mathematics. And also he says he would like to do mathematics without any logic or calculation. So, but maybe many people will disagree with him, but for mathematicians, it's kind of quite essential. What he's saying is quite essential to mathematics. So mathematics is not a world of just logic. We need some kind of sense of empathies in order to discover something new. And also mathematics has sometimes infinite solutions or infinite perspectives. So it's very free. So we can see things from various points of view. It's quite interesting. So those 3 points are what I think mathematics is. So from here, I would like to challenge you with some equations or problems. So please enjoy it. Okay, first, this is equations. These are equations which I really think beautiful. And when I was 15 or 16 years old, I came to know this equation, and I really got surprised. And even though right now I already know some proofs, some proofs for these equations, but still, I think I cannot understand this exactly. So here, on the left hand, so it means 1 plus 1 divided by 4, 1 plus da 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 da. So 1 divided by square are all summed up here. Then it will somehow reach to pi square divided by 6. Do you know this equation? No? Maybe some of you may know. And as for the second one, these are very quite similar. Not square, but triple. But still, we don't know what it is. So it's an unsolved problem. So if some of you can try this, you must become a very famous person in the world. Yeah. And here, this is also very, very beautiful. 1 minus 1 divided by 3 plus 1 divided by 5 minus blah, 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 blah. Then it reaches to pi divided by 4. So this is also quite beautiful, I think, because here on the left side, we cannot see any pi. All we see is kind of many natural integers. But on the right side, suddenly pi will appear. And also this one. I'm sure everyone will disagree with me on this equation. Yeah, but for some mathematicians, they think this is right in a sense. So if you look at the left-hand side from a different perspective, sometimes for some mathematicians, it seems to us that it is minus 1 divided by 12. Yeah, so it's kind of a really mysterious world. But mathematics sometimes tells us that things are not always just we see. So sometimes if you look at things from many, many various perspectives, sometimes the essence of the things or equations will appear. Yeah. So these are the equations I really love in mathematics. Here, so I would like you to think which prime numbers can be written as a sum of square of integers. For example, 2. Now, 2 is an exceptional prime. But anyway, 2 can be expressed as 1 plus 1. Yeah, 1 is 1 square. So 1 square plus 1 square. But 3 cannot be expressed like that. But 5 is 1 plus 4. 1 square plus 2 square. Are you following me? Okay. So how about 7? Yes or no? No. Oh, no, yes. How about 11? No. How about 13?
Yes.
Yes. Oh, thank you. How about 17?
Yes.
Yes. How about 19?
No.
No. Okay. So how about 41?
Yes.
Yes. What plus what?
16 plus 12.
Yes, 16 plus 25. So it would be like this. And how about, okay, anyone, any number. How about 67? 67. You can be wrong. Yeah. In mathematics, it's really important to fail. So, no. Okay, yes, you're right. And how about 101? Yes, yeah, it's quite simple. Yeah, so something like this. So you can do, this is kind of a asobi. So you can try anything, I don't know, any prime number. You can try any prime number maybe at your home. But right now, I don't have enough time, so I will show these. So, and I'd like to ask you, what kind of prime numbers have yes? And what kind of prime numbers are no?
It is 1 module 4.
Oh, there is a genius here. Okay. Any others? So he said modulo 4. Modulo 4. So if you divide these prime numbers by 4, those who have yes have a remainder 1 or 2, but 2 is really exception. So except for 2, those have a remainder 1 is yes, are yes, and those who have remainder 3 are no. So here, actually, there is a very, very beautiful and deep theory in the back, actually. So at the university, I was actually studied a lot. I studied a lot on these kind of things. Yes, for me, it's quite interesting. And so here, if you write x squared plus y squared equals to something like this, so using I, imaginary unit, you can express this like this. So it means if you allow I to become kind of integer, so integer plus integer times I are another new integer, then these number, for example, 13, are not anymore a prime number. That means 13 equals to 2 times 3i times 3 minus 3i. Yeah. So prime number sometimes changes into the product of 2 numbers. So things can be different. If you stay here, they are prime numbers. But if you go up to the next, more upward, some prime numbers will be divided into 2 parts, or sometimes maybe 3 or 4. Yes, so these kind of things. Yeah. So one more. Yes, one more. So this is policeman, and this is a thief. So please try to catch a thief. So policeman would like to catch a thief, and thief would like to run away from the policeman. So the rule is that policeman first will go by only one step. Yeah. And then thief will run away from police by one step. And they take turns. So for example, police go here, thief go here, and the police will follow a thief, then thief maybe go down here. Yes. And try to catch the policeman. No, catch a thief. Maybe it's better to use this whiteboard. So can you please think a little bit, and if you find a solution. Oh, sorry. Okay, just if you find a solution, please let me know. So this is kind of a really game, just a game. But here you have to use your sense, not just the logic, maybe. So if you try, maybe it might be difficult for a policeman to catch a thief. So you have to change your ideas. You have to try other ideas. Can someone beat me? You're almost done. Are you? Yeah.
Maybe
Yeah.
because maybe audience will be better.
Anyone? I will try to run away from here. So, yeah. Please try me. So first policeman is here, see if he's here. Policeman go by one step. A thief will go.
To take the step, right?
Yep. Yes. You cannot say no or pass, or you cannot say.
The policeman should go right.
Should where?
Go right.
Go right first, okay? Oh, okay. Could you please come here? Yeah, it's better. Yeah. Please. Yeah, go right. Okay, first, so the policeman. You do it, okay. So maybe you get an idea.
Where you're going. Okay, so you said
Okay, you're
first
here.
go here, right?
Okay, so I will go here.
Okay, so thief is there. I'll
Yeah,
point.
maybe it's better to switch.
Okay.
Yes.
Oh, here.
Okay, a thief will follow a policeman.
Let's see.
Oh. Yeah, thank you so much. Thank you. Okay, so what's the key here? Can you say that? What was the key?
Like when you start out,
Yes.
necessarily
Yeah.
some multiple spaces.
Yes.
Going through the triangle.
Yeah, thank you. Yeah, you are quite right. Maybe, yeah, there are many geniuses here. So, yeah, so as he said, so like this, if you paint the dots like red and yellow, when policemen go to yellow, a thief also go to yellow, and policemen go to red, a thief also goes to red. So that means if policeman just go around here, he never can get the thief. So policeman has to go here. So maybe you can sense something is different here. So if a policeman try to go up here, then he can catch. Yes, something like this. So this is kind of just a game, but you can see many ideas. So in our actual life, sometimes you are really keen on following somebody and catching up him, but sometimes you have to change your ideas and use your senses, and you have to find new ideas to solve the problem. Yes. Okay, so this one I'd like to try, but I will skip. Okay, so here are some works of children. Like this one is work of a 6-year-old girl, and this is a work of a 9-year-old girl. I'm actually in the Central Judging Committee of 算数数学の自由研究. So free research on mathematics and arithmetics. So from 6 to 17, 18 years old, they can challenge this 自由研究 in their during their summer vacation. And now, I've been in the Central Committee for 3 years, but now we are having as many as 15,000 works from not only in Japan, but from all over the world. And this is quite interesting. Because first, even for a mathematician, we thought that it might be really difficult for children to think up some new discovery or new researches on mathematics or arithmetics. But we were wrong. Their works are really, really interesting, so I'm really having a lot of fun in viewing these works. So for example here, she tried to search what can be the biggest shape made by one rope. Yes, so she tried to make many various shapes with that rope, and she tried to find the size with the beads inside. So she found out that the circle can be the most biggest one, or something like that. But this was done by a 6-year-old girl. And also, this one is also a 9-year-old girl's work, and she tried to make a sand clock of 3 minutes. So using just addition, subtraction, multiples, and division, she made that. So using mathematics, we can do anything actually. So I think maybe many people sometimes hate mathematics, especially in Japan. But mathematics is everywhere. And also in mathematics, everything is kind of free. So we can set any new ideas and try to make something new with a logic and a sense. So if you like to discover something from around us, you can find many mathematics around here. Yes. So it's quite interesting. Others are like, is it really good to set the best batter on the first in the baseball batting order? This was done by high school students. And also, this was a kind of famous work. So maybe you know Hashire Melosu by Dazai Osamu. So she tried to research how fast Melos was running. And he found out that Melos was not running actually. So he said that please hashire yo Melos. Yeah, please run more Melos. Yeah, so Melos should have run more. Yeah. So here, so for example, even from one theme or one problem, we can get many ideas. So here, using this problem, so here there are 5 small squares of area 1. Using scissors and tapes, please make a big square whose area is 5. Then they tried a lot, and many people from all over Japan tried, and from 6 to 65, and they made each original works. So there are infinite solutions, infinite answers here. So math is really a world of freedom. Okay, so next, music. Music is also has 3 points, just as mathematics. Music is beautiful and sometimes mysterious, especially jazz music. Improvisational music can be really mysterious. So this is some music for just now. So music can be really beautiful and mysterious and touches our heart. And also maybe you all agree that we need some kind of joncho or sense of empathy in music too. And also at music, we can have infinite free perspectives. Yes. So through music, so not just copying the score, playing just as the score says, or sing just as the score says, but also we can try to compose our own music. Mathematics and music are not just for mathematicians or professional composers. Anyone can try to do that. And I think it's quite interesting. So if you can compose some kind of original music using your hanauta maybe sometimes, yeah. So before going to improvisation, I'd like to introduce you one man, my mentor. His name is Takehiro Honda. But actually, he is a really great jazz pianist and famous jazz pianist and composer in Japan. But when I first met with him, he just revived of miracle from a big disease, actually. So he was paralyzed on his left side from strokes. So he had strokes 2 or 3 times. And the doctor said that your left side is no longer works. So, but he really loved music and loved piano. So in the rehabilitation hotel, there was a piano. So he asked the doctor, and he practiced all day long, every day. And after a while, he made a miracle. And that's just when I met with him. And I was really moved by his way of living and also his music itself. I know his past works too, but for me, it was really kind of shocking for me that he made a miracle. And so this is also one of a very big key element that I was moved to go with the music life. Yes. So he's my mentor. And so music is somehow a story of how you live. And even when you listen to music, it reflects how you live. So it's very similar to paintings, but I think it's also similar to mathematics too. But as for music, it's quite direct to our daily lives. And also at music, sometimes we can have infinite possibilities. For example, for improvisation, we can use our imagination to connect dots. So, for example, using do, ra, do, mi, do, mi, so, do, re, fa, sharp, or something. So, using do as a connector, we can go anywhere. So we can link many, sometimes chords or melodies or rhythms, and we can get to anywhere. So here, I'd like to try an improvisation with your help. So right now, I would like you to give me 4 notes, maybe. Yeah, 4 notes and 1 theme. Yeah, 1 theme. And I'd like to try to make an improvisation using those 4 notes and C. So could you please give me 4 notes, one by one? Yeah, like do or fa sharp or. So sometimes it can be really simple and easy, but sometimes it can be really difficult for me. So first, today I'm not sure what's going on, what's real, happen here today. Yeah, thank you. Me, okay, thank you. Me first.
She.
T, okay, she, T. Me, T, and
B flat. B flat.
me flat. Okay, okay, me flat. Okay, and one more. One more.
Fa.
Fa. Oh. Kind of a difficult one. Yeah, it sounds like. Sorry. B, T, B flat, fa. Quite mysterious. Yeah. And one theme, please. Any theme.
Future.
The future. Wow, great. Thank you so much. The other day I was given pie. The theme, and it was difficult for me. But future. Oh, great. Okay, so so sometimes we can use these 4 notes with chords like this. Very mysterious. Okay, or something like this. Yeah, so I will try to connect many ideas and make some story using these 4 notes. future. Yeah, so music is a world of imagination. So you can imagine any. So sometimes for these people it's future, but those people it's kind of a very dark past or something. So it's quite interesting for me that we are different from each other. So in mathematics and music are, I think, quite similar to each other. So, yes. Sometimes, of course, in music, there is a mathematical logic. But not just that. Music and math are quite similar to each other because they are the world to create something new. And also lives are too. Sometimes in your life, maybe in my life too, I have to struggle with something which I cannot conquer. So that means it's kind of a mathematical problem or kind of a slump in music. It's quite similar to each other. But there we have to use our senses and sometimes logics to free ourselves from any bias or prejudice. We have to try something new. So yes, for me, music, math, and lives are quite similar to each other because they are the word to create something new. So here, his name is Cédric Villani. Do you know Cédric Villani? He's a French mathematician, and he won the Fields Medal. Fields Prize is like a Nobel Prize in mathematics. It's really, really great prize. So he has got that, and his passion is also quite impressive. And he said that Lady Gaga in mathematics. Yeah. And he really loves music too. And some of his brothers are composers, and he sometimes have a seminar with the composers about creativity in France. And we had a very interesting discussion there about music and mathematics. And also here, like Katsushika Hokusai, he's famous that he used mathematics in designing his paintings. So maybe you know Leonardo da Vinci too. And so many painters are also used mathematics, and also musicians too. So artists and mathematics are quite similar to each other. They can inspire with each other. Science or mathematics can inspire artists, and artists can also inspire scientists and mathematicians. So yeah, so if you look at things, and if you see circle from the top and the triangle from the front, you may think that this can be a figure, something like this. But it might be a figure, something like this. So from a side, you can see the square. So even from the front, it is a triangle. From the top, it is a circle. But from the side, it is a square. So, and maybe from inside, maybe it can be really, I'm not sure what's inside. So things can be really different, and in order to get closer to the essence of the things, you have to use your imagination, and also you have to use a very free attitudes to look at things. So inspired by these kind of things or scientific development, Picasso or Cézanne studied Cubism actually. So at Cubism, there are various viewpoints are in the same paintings. So in order to get closer to the essence, they put a different perspectives on the same paintings. So I'm sure that Picasso and Cézanne, all of them were inspired by mathematics and physics, science. So also, of course, we have the mathematics in music too. For example, if you the sound is a kind of a wave, yes. So you like to double the frequency of this wave, it can be something like this. This is a double one. So if you like to triple third times of this do, you will have. This is a sound of 3, actually. This is 1, 3. Yeah, this is the sound of 3. And if you like to hear the sound of 4, 2 octaves sound of 4. 5. This is 5 sound. And 6. Sorry, no. 5 sound is something like this. Do, mi. So here, if you play do, mi, it means 4 versus 5. So this is a sound of 5 and 6. And 7 is similar to this. 8. 9. And 10. So maybe you can see that a very close tone, like 2, 3, 4, 5. Harmony is quite beautiful for maybe Western people. Sometimes for Japanese people love this kind of very complicated sound. But if you just listen to very simple notes, maybe you feel that these harmonies are quite beautiful, simple. And going over and over, sometimes you can get a very kind of dark or dirty sound. For example, here, it's a sound of square 2. Square 2 is something like that, which is often used in in maybe mysterious movie or something. Yes, so we have 5 minutes left, and so now as for education side too, for me it's quite similar to each other. So they are beautiful and mysterious. We are beautiful and mysterious, I believe, and we need a sense of empathy or feel of sense of essences over logic, and also sometimes we need infinite free perspectives towards the things. So in order to survive in this 21st century here, right now, in this VUCA world, volatility, uncertainty, complexity, ambiguity, so things are changing very fast right now. So here we have to have a sense of empathy, and also we have to see things with very, very infinite way perspectives. Okay, so I think for anybody, mathematics and music are really important. And for me, I have 2 challenges in 2016, so I would like to introduce this, and I would like to finish this talk. So first challenge is a collaboration of artists. He is Mr. Satoshi Okada, a very well-known artist, international architect. He has actually won Dedalo Menosse International Prize in Italy. He won the Grand Prix there. And yes, he's based on simplicity, which is his core value, he reached deep spirituality in his architect. Here is an example of his art. So you can check on the internet of his works. So he will go to Biennale. He was selected as a very great architect at Biennale 2016 again. And this year, the theme is time, space, and existence. And he decided to collaborate with artists. So we are now trying to make one work, collaborating with each other. He is an architect, and Tsuboi-san, videographer, and me, just being my composer or musician. And also maybe Gugu also might help us a little bit. The other challenge was for education. So we like to collaborate as an artist, and also with those powers, we like to start some new learning, experiential learning. At Phoenix Consulting, we are doing for corporations, and also we like to do those kind of new learning, new creative learning for children too. STEAM. STEAM is STEM plus art. So we are now in 2016. We are now challenging a new learning style with a power of artists and technologists. So, lastly, so I think what we need in the 21st century right now is kind of first jojo, and also imagination to connect dots, and also last, but maybe most important is the courage to fail. Like Einstein says, a person who never made a mistake, never tried anything new. So I think the courage to fail is really, really important now, because things are changing. We have to have a courage to fail first. Yeah. So what I'm doing right now is like this, and I'd like to go on my lives like this, and we'd like to collaborate with each of you someday in my future. So thank you very much. Thank you very much.